Although it is very rare that you will encounter an installation fault, mistakes do occasionally happen. Feeders could be incorrectly terminated or even accidentally damaged by other site workers. It is more likely that an equipment maintainer will come across accidental damage and a radio site will be taken out of traffic due to an antenna system fault. Once the existence of a fault has been identified, we need to find out just where the fault lies. It is advisable to inspect the antenna system, following the feeder cables from the radio room, along the cable route, and onto the antenna. This act alone may reveal damage to cables. It will also give you a rough idea as to the approximate feeder length, although feeder length information should be available in the site documents. Our intrepid tester should already have set the test frequency limits and calibrated the instrument. Good. Then we can continue. Connect the sitemaster's extension cable to the antenna system that is to be tested. To take a distance to fault measurement, press the Mode key. The up-down key will scroll the display up and down the screen menu. Select DTF SWR and press the Enter key. Enter the cable start and end distances by setting the D1 and D2 parameters. When the sitemaster was calibrated, the test load was connected to the instrument via an extension cable. This extension cable is now a part of the instrument and its calibration. As far as the distance measurement is concerned, the end of the extension cable has become 0 meters, the calibration point. If you had, for example, a 1 meter jumper cable between the feeder and the calibration point, then the jumper cable would become a part of the antenna system being measured, and D1 would be set to 0 meters. You may, however, wish to exclude the 1 meter jumper cable from the distance measurement and only measure the feeder cable. In this case, D1 should be set to 1 meter, as in our example. So let us now set the D1 and D2 parameters. Press the D1 soft key and use the up-down key to move the parameter to 1 meter. Press the Enter key to enter the data. Press D2 and use the up-down key to move the marker to a number of meters that you know to be greater than the total feeder length. Press the Enter key to enter the data. Press the More soft key and you will be able to select the cable type. Here you tell the instrument information regarding the properties of the cable so that a distance calculation can be made. Press the Cable soft key and select the cable manufacturer's measuring method, then the cable type number from a list. This information is given by the cable manufacturer. We, however, have a cable that is not programmed into the sitemaster, so we have to enter both the cable parameters manually. We need to set the loss and propagation velocity factor. To tell the sitemaster our cable loss factor, press the Loss soft key and enter the data, which in our case is 0.069 decibels per meter. Press the Prop Vel soft key and enter the propagation velocity, which in our case is 0.88. When you have done this, press the Enter key. Press the Back soft key to return to the Distance to Fault screen. You should be aware that the cable loss and velocity factor settings have a large effect on the accuracy of the reading. The sitemaster will repeatedly measure and calculate the display points. If there should be a fault on the cable, then you will see an elevated reading. Any elevated fault reading on the graph can be directly read against the bottom scale of the display as a distance in meters to the fault. You could use markers to find the peak and give you a more accurate reading of the distance. Markers are described in the Spectrum Analyzer video film. In our example, we have a large VSWR disturbance at about 30 meters, which just happens to be the end of the cable. So now you know the location of the fault. It is just to inspect that part of the antenna system more closely to locate the fault. The most accurate reading will be obtained when the antenna is disconnected and a 50 ohm calibrated load is substituted. Incidentally, if you need to save the display, then save the VSWR data, not this distance to fault screen. Distance to fault and other data may then be recalculated later.